Hello, wonderful chemists. Today we're going to look at how we can classify the elements on the periodic table in different ways. So the first way that we're going to kind of classify them is by whether that element is a metal, nonmetal, or a metalloid. So to do that, we first need to draw something called the staircase. So what you want to do is you want to find first boron and aluminum, and you draw a line in between them. So have some markers or crayons ready. Stop this video, have some markers or crayons ready, and then play it again when you are ready. But the first thing we're going to do is we are going to draw a line in between boron and aluminum, and then from there we're going to draw a staircase. So we're going to go down, across, and so on. So down, across, down, across, down, across, down. Don't worry about the elements that are in the 7th period right here. Those have just recently been discovered and we don't really know much about them. Most of them don't last for very long, so don't worry about those. All right, so the elements that are around the staircase, those are your metalloids. And so I'm going to go ahead and mark that as green. And so boron, silicon, germanium, arsenic and antimony, tellurium and polonium. And you know, I wouldn't worry about the acetine much. Don't worry about that one. It's one of the rarest elements in the world, so don't worry about those. We're just going to stick with these as our metalloids. Everything to the right of that staircase is a nonmetal. So all of these right here are your nonmetals. I'm going to color those red or pink. And all the nonmetals are to the right except for hydrogen. Hydrogen is also a nonmetal, but it is right here on this side. Everything else is a metal. I'm going to color those blue, so anything to the left of the staircase, with the exception of hydrogen, is a metal, including those inner transition metals there. So it's a lot of coloring to do. And if you'd like, you can just outline them as opposed to, color them in. It's really up to you. But these are all metals. So you can see there's a lot more metals than nonmetals or metalloids on the periodic table. Okay. So now that we've colored them in, let's talk about some of their properties. And a lot of this should be review for you. I know a lot of you did not do metalloids, but I know that you've done probably metals and nonmetals before. So let's start with metals. You're probably most familiar with metals. I'm going to move it this way a little bit. That way we can read. Okay, so lots of metals on the periodic table. Let's list some examples. So copper, gold, silver, iron, cobalt, nickel, lots and lots of different metals. Metals are shiny. They're lustrous. They have luster. They're malleable. That means you can bend them. They won't break. They're ductile. That means you can pull them into a wire. So lots of the wires that we have are metallic. They conduct both electricity and heat. So that's why our pots that we cook with are metal, so they can conduct heat. That's why our wires for computers and electronics and things like that are metals, because they conduct electricity. Let's look at some examples of nonmetals. So nonmetals are like carbon, sulfur, hydrogen, oxygen, nitrogen, lots of different ones. These are dull, not shiny. They're brittle, not malleable, not ductile. They do not conduct. Metals are mostly solids at room temperature. With one exception, which is mercury. Mercury is a liquid. For nonmetals, some are solids, some are gases, and there's only one nonmetal that's a liquid, which is bromine. So bromine is the only liquid nonmetal. Mercury is the only liquid metal. All right, well, what about metalloids? What are metalloids exactly? So metalloids are elements that have some properties of metals and some properties of nonmetals. So, for example, some of them are shiny, some are dull. Some conduct electricity, some don't. Some are semiconductors. Some are ductile and malleable. Others are brittle. And so each of these nonmetals that we have, each of those metalloids that we have different properties from each other. But they are kind of in between. The most common one of these, I think, is silicon. Silicon Valley is named after silicon, which is very different from silicone, so make sure you make the distinction. Silicone, which is not an element, it's a compound, it looks kind of like plastic. But silicon, the element, Si, that is this beautiful crystal that is brittle, but at the same time shiny. It's a semiconductor, so it's a pretty cool element. And like I said, it's shiny kind of like metals, but it's brittle like nonmetals. It's semiconductor, so it's in between. And so metalloids are kind of like, they don't really fit in either category. They're kind of a combination of both. The reason why they call Silicon Valley its name is because silicon is used to make computer chips and electronic chips. So that is why. So that's one way to kind of divide the elements on the periodic table. Another way is by families. So we're going to color the families of the periodic table in this video, and then in the next video we'll talk more about, like, the properties of each of those families. So we're going to start with the first family, which is the alkali metals. So I'm going to do those as yellow. Make sure you you color your key here. So this is group 1, lithium, sodium, potassium, rubidium, cesium, and francium. group 1. Next are the alkaline earth metals, group 2. Beryllium, magnesium, calcium, strontium, barium, and radium. Next, we're going to color the transition metals. So those are group 3 all the way to group 12. This big block on the periodic table here. And again, if it's a lot of coloring, you can always just highlight them instead of color them in. All right. Next are my inner transition metals. So those are actually on the bottom of the periodic table. In reality, they belong in the middle of the periodic table. They actually belong right here. But we put them down because that way it's easier to print a periodic table. That's really the only reason. So that it fits nicely on a piece of paper when we print it. Okay. Next one, let's do the metalloids. Before we do the metalloids, we probably want to do the staircase here. So remember the staircase is between boron and aluminum, and then you go down, across, down, across, down, across, and so on. So I'm going to go ahead and color my metalloids. I'll do them purple. So boron, silicon, germanium, arsenic, antimony, tellurium, and polonium here. Okay. Next we're going to color the halogens. I'll do this color here. So halogens are group 17. Fluorine, chlorine, bromine, and iodine. It is up to you if you want to color in astatine, which is AT. Like I said, it's basically the rarest element on Earth and naturally occurring one. And so, you know, we haven't really studied it. It doesn't seem to have the same properties as the rest of the halogens. So I'm not going to ask you about astatine. It's not something that you need to know about. Okay, let's go with orange next. Let's do the noble gases. So the noble gases are the last group on the periodic table, group 18, right here. Helium, neon, argon, krypton, xenon, radon. And then let's find a color for the other nonmetals. What color did we not use? Let's go with that. So let's do the other nonmetals with this color. So those would be these right here. There's just whatever nonmetals were left that we didn't really color in. Don't forget hydrogen is a nonmetal. And then we're going to leave the other metals in white here. So those right here would be your other metals. Okay. On the periodic table, there are periods and there are families or groups. So periods are the ones that go across. So when you go across, so across a period, and so those are the horizontal ones. Okay, and then going down say down a group or down a family. So those are the vertical ones. And on the periodic table, groups or families are the ones that have similar properties. So families, you know, if you think about it, like when you think about your family, they have similar traits as you, they look kind of like you, they behave sometimes like you. And so the elements in the same family or group behave similarly. So if you, for example, look at lithium, sodium, potassium, rubidium, cesium, francium, these are all alkali metals. These are all have similar properties. Group 2 have similar properties. Transition metals have similar properties. Halogens have similar properties, and so on. So groups and families are the ones that are vertical, going down. Periods are the ones that go across. All right, that is it for coloring. The next video you're going to watch is going to be going over the properties of the different groups or families in the periodic table. Have a great day. Bye.